So how you start this up is, like we said, square root of each part separate. Okay? And remember, why we can do the square root of each part separate is because this is just one term. If it was 12x cubed plus y cubed z to the fourth, you couldn't break up the two parts. But because it's multiplication between all those little parts inside, you can do this. Right? So just keep that in mind. We're able to do this because it's multiplication. It's really just one term. I know it looks larger than what you're used to, but because it's separated with multiplication, it still is just one term. So you can do this to one term. Right? Now each part of this is almost separate. It's like when we usually talk about taking really large problems and breaking them up into smaller problems. This is that. Okay? So when we look at this, remember, you're going to hear me ask you the same questions over and over and over on how you set this up. Reason being is because as you're home and you're doing your work and you're taking your quiz and you're taking your test and you're taking your midterm, which is in a couple days, you're going to, when you do these problems, you're going to ask yourself, is it a perfect root? If so, if the answer is yes, then you just take the root and go and you're done. Okay? If it's not a perfect square, if it's not a perfect root, then you have to go through and simplify. Are there any perfect square factors? Are there any perfect root factors? All right? So, we look at this first one, 12. Is 12 a perfect square? No. What's a perfect square factor of 12? 4. 4 and 3. All right? What's the square root of 4? 2. So that's good for us. Once we get to a number, we box it. Now, root 3. Is root 3 a perfect square? No. All right? Doesn't have any perfect square factors. Yeah. All right, so we box that up. Give you a little tip.
Okay. So you know how you said that like the index can't be bigger than the exponent? Well, how come like for the square root of 4, like it goes like you can simplify it to 2, but isn't the index bigger than the exponents?
But you're still simplifying just the number. If you rewrote 4, you would rewrite 4 as 2 squared. And there your exponent is the same as your index. And if you just put it in your calculator, 4 to the 1/2, 4 to the 1/2 is the same as taking the square root. So if you went based off of strictly what you said, and you actually evaluated 4 to the 1/2, you would still get 2. That's another way. If your calculators didn't have square root signs on, the buttons on there, that's how you would be taught to do it on your calculator, by raising it to the 1/2 power, or raising it to the 1/3 power if it was a cube root. Right? But if you think about 4 in terms of how you would write it in its simplest exponential form, it would be 2 squared. And then your index and your exponent are the same. All right? Now, also, look at 3. What do you notice about, what kind of number is 3? Think about factors. Prime. Could prime numbers ever be simplified under a radical? No. So if you notice you have a prime number there, you know, any prime number you can think of, you know you're going to be done there. Okay? Keep that in mind, because it saves you from trying to think, is it a perfect square, is it a perfect root? You know, it might cut down some time saying, well, that's a prime number. I know the only factors of a prime number are 1 in itself, and a number can't be prime and a perfect square at the same time. Okay? So that's something to keep in mind. All right? Now, root 3, these next two are going to be done very similar, but that's all right. What's the square root of x cubed? That's not the square root of x cubed. You can't do it. But what's a perfect square factor of x cubed? There you go. Now we can say that. So it's x squared and x to the first. What's the square root of x squared?
X.
Just x. Just bring it down. X. And can we do anything to this?
No.
Why? Say it again.
Because
The index is bigger than the exponent. Okay? That frame of mind, that thinking applies more or less when you're dealing with variables. Okay? So remember, we box up this x because we know we're done. We box up this root x because we know we're done. Okay? We move on. The y's are going to work the same way. It's the same questions. It's the same answers except now with y's. Okay? Again, is y cubed a perfect square? No. What's a perfect square factor? All you have to do is gather up enough y's in this case in order to get rid of a square. Right? So, the last part. Is z to the 4th a perfect square?
Yep.
Yeah, so we don't have to worry about anything. What's the square root of z to the fourth? Z squared. So we have z squared here, right? Now, can we do anything more with z squared? But it's a perfect square. Why can't we make it z?
There's no square root.
Because there's no radicals. Everything that you guys are saying is right. Don't make things up. Don't do more than you have to. Okay? This is perfectly fine to stop with right here. Because there's nothing more you can do to a z squared. You can simplify a square root of z squared. Well, I'm in agreement there. I'm totally on your side on that one. But don't do more than you can. Okay? Don't do more than you can. So, let's box this guy up. Now, what's not under a radical sign? 2x, 2x, y, z squared. Just what you said, right? All right, now the last part. What's still inside a radical sign? 3x, y. So, there you go. Okay, now before you finish, what I would suggest you to do is take a look at what's inside your radical sign and give yourself another quick check. Can you simplify root 3? No. Can you simplify x? Can you simplify y? No. So make sure before you say I'm all finished and I'm all done and I'm moving on to number 2, make sure what you have written is working for you. All right?